Is that
That one with basically the entire ocean is red. It should be like the fourth one I sent you. It says January to December SIG trend.
okay? I gotcha. I got it.
Okay, if you look at that one there, again, where do you see where it's cooler? It's off of Greenland and off of the Antarctic Peninsula. But the entire oceans is red. That's basically for the past year. Okay, the other ones were warmest decade. This is for the past year.
And this was that idea of 2000. 2019 was the warmest
Right. Exactly.
ocean.
This shows it. That graphic shows it right there.
Wow.
So, I mean, the entire oceans are basically red. And if you look at the scale below, it tells you what the, you know, it's at least 1 degree. Well, let's see. Okay, that's in
Oh yeah.
from trend significance. So -1 to +1. So the significance is greater than 0.95, which is 97.6%. So what that means is that this is significantly different than the average. That's what that's telling us.
We are way above average.
Yes, it's basically saying that warmest temperature that we recorded is significantly different. It is significantly different from the average trend for that 1 year, which means you cannot account that for just randomness. That something's going on. That's what
All the
that graph.
energy the oceans are absorbing.
Yeah, exactly. So that is what that graph tells us.
Let's see. We basically hit them all, the ones you sent me. Essentially, the oceans are red, indicating they're way above average. The blue spots can be linked to the ice coming off of Greenland or Antarctica, which was interesting. I had no idea about that.
With the cold oceanic temperatures, the cold is given off into the atmosphere as well. So that explains why those areas are. And if you look at most graphs, they're always typically below average just because of that.
Okay.
And interestingly enough, that is in the general vicinity for what's called the Jin Sea, Greenland, Icelandic, Norwegian Sea, which is where the Gulf Stream kind of finds its way up to. It gives off its heat, which is why it's a little warmer to the east of that blue blob, because that's pretty much where the Gulf Stream is terminating. It gets called the northward drift at that point because it does slow down. That's why Scandinavia and the UK are warmer than they should be for those latitudes. And so it gives off its heat. It's now very cold water. It's also very salty, so it's very dense.
Okay.
And cold, salty water that's very dense sinks. And this is where the conveyor belt starts, what's called the Atlantic Meridional Overturn Circulation, AMOC. That's where it sinks and starts its flow back south. And the conveyor belt is really a heat distribution mechanism for the entire planet.
And you can see the entire land, all the land masses are red.
Yeah.
So,
and here's the thing though, I am actually one of those folks, one of those oceanographers who's of the opinion that global warming will bring us into an ice age eventually.
okay, yeah, I think I know what you're talking about. Because over time, right, we're still in an ice age technically, correct?
We're interglacial.
Interglacial.
Yeah.
And then, damn, so I'm going to mess up with the term, so forgive me. But so
no problem.
As we're going into a warming period, I've seen graphs, I don't know how accurate they are, I can't specifically tell you which ones, but I remember in the past where down, a couple thousand years, we're going back, even we're dropping again. We're going back into an ice age. So do you want to elaborate what you know?
What drives that, in my opinion, is that as you continue to melt Greenland, let's just stick with Greenland. Okay. You're now putting what's called a freshwater lens on the surface of the ocean. Well, fresh water doesn't have much salt in it. So you're decreasing the salinity of the surface waters. So you have cold waters, but it's not as dense as before, so it's not going to sink as readily. So now if that water doesn't sink, what happens is you take in, the way the conveyor belt works is it takes cold water, cold heat energy from the poles, brings it to the tropics. In return, it takes warm water from temperate zone, brings it to the polar region. That's why I said it's a heat distribution mechanism. It helps moderate, reduce the gradients, if you will, of temperatures worldwide. Well, if you start shutting down the conveyor belt, as it's colloquially called, you're going to keep the cold in the polar, and you're going to keep the hot in the tropics. You can have a greater gradient of temperature, but also this promotes the growth of ice sheets. And there have actually it's already been documented. Oceanographers, especially from Dalhousie University in Halifax, Nova Scotia, have already measured a slowdown in the deep water formation in the North Atlantic. It's slowing down. The late Wally Broker, he's kind of like the grandfather of all climate, using isotopes for dating and all kind of stuff there. I did a video on him when he died. But anyway, he basically showed that the conveyor belt can shut down in a matter of decades.
Wow.
Now, the issue here is that, okay, so it shuts down, but there is so much thermal inertia in the system that there's enough heat there to carry on. New modeling has now indicated that even if the conveyor belt were to shut down, there's still enough thermal inertia in the system that the planet itself won't really start cooling down to an ice age for another 500 to 1,000 years. So it won't be instantaneous. And of course, that ties into the specific heat capacity of water and so forth. But there's quite a long lag time from when it shuts down to when it starts cooling down significantly to create ice sheets, and then in reverse when it goes the other way and get the conveyor belt flowing again.
Okay. So we're going through a warming period and then essentially a cooling
because we're
off.
melting the ice sheets and we're adding the freshwater layer to the surface, makes the water less dense so it doesn't sink, so it doesn't bring down the heat. But here's the other thing. When that water is traveling south, and it sinks down to about 1,000 meters or so, it's called the North Atlantic deep water at that point. It continues going south. It branches into the Indian, into the Pacific Ocean, but there's a section that starts to come up to the surface called upwelling, because as it's flowing, it's rubbing with other water masses. That's friction. Friction imparts a little bit of heat. Doesn't take much, and it starts upwelling. As it upwells, it's bringing nutrients that are down there, minor macronutrients, micronutrients, whatever, minor nutrient. It brings that up to the surface, which the phytoplankton need, into a region called the Antarctic Divergence Zone. The Antarctic Divergence Zone is it's in the Southern Ocean. It's the world's most productive open ocean system on the planet. Most oceans are biological deserts. You get most productivity near the coast, upwelling, shelf production, that kind of stuff there. The Southern Ocean, because of that upwelling, is productive. That's where you get your big baleen whales eating all the krill and so on and so forth. You shut down the conveyor belt, that upwelling doesn't happen.
Mm-hmm.
That whole ecosystem collapses.
It's catastrophic.
I mean, seriously, that whole ecosystem will collapse.
And you're talking about decades, not centuries.
For the conveyor belt itself to, well, it can shut down in decades, but for the effects temperature-wise, it will be centuries.
Okay.
The Antarctic Divergence Zone will be affected within decades because there's no more upwelling.
What are we going to do with our life?
There's a lot of things that have been set in motion.
I know. And it's hard because, it's going to take some time, but man.
I know it's a lot to process.
I think I'm getting it. I have to process, but it's good. I understand what you're trying to say. So Man. What do you want to talk about next week, Jeff?
Was there any other graphics or that you had up on the docket?
So I only had the 1, 2, 3, 4, 5. I had the 5. We want to take another quick look at the temperature spike one.
Oh, okay, sure. Let me refresh my memory on that one, although I think it's pretty.
The title of it is "Percent of Earth with Warmest and Coldest Decade Since 1900."
Right. And it basically, you can see the switch over from the 70s to the present day, where it became warmer than colder in the 70s, 80s, 90s, starting in the 2000s, and then the 2010s, it's like just jumped off the chart there for the warmest. And while the coldest is pretty much flatlined at zero for the most part. So what this is telling us is that for the percentage of the Earth with the coldest decade since the 70s, there's been none. Is really what that's telling us. The coldest decade was the tens, the 1910s.
Really 100 years ago.
In fact, if you look at it before 1970, the warmest decade was pretty much flatlined. But 1970s is the switchover where the cold and the warms reverse themselves.
And what are these numbers above the little diamonds?
Okay.
Above 1980s, it says.
Pull that up there.
Okay.
That would be the percent of the Earth's surface. So if you look at 4.3 and then 0.1, that tells you what percent was warmer, was the warmest, or the coldest. So basically 4.4% warmest and coldest. So you have what, 95.6% is average. And you subtract them out. But then you get to the 2010s, and basically we're pushing 77% of the planet is the warmest it's ever experienced. That to me is a shocking graph.
Yeah, it is.
That's just, I mean, that along with the sea surface temperature for 2019 kind of encapsulates what's been going on and how things have really kicked in the last decade.
And it's just the acceleration is just amazing.
It is. It's showing the exponential increase, not linear. That's what it's showing.
Yeah, how fast things have really changed in such a short amount of time.
Absolutely.